Hello, sixth graders. Welcome to lessons 13.5 and 13.6. These lessons focus on choosing and applying appropriate measures of center and variability. 13.5, we're going to take a look at choosing the methods of finding center and variability that fits that problem best. Outliers, gaps, and clusters in a set of data can affect both the measures of center and variability. Some measures of center and variability may describe a particular set of data better than others, based on the questions that they are asking and the problem that we're trying to solve. So this first one, Thomas is writing an article for the school newsletter about a paper airplane competition. In the distance category, Kara's airplanes flew those distances. Should Thomas use mean, median, or mode to best describe Kara's results? Explain your reasoning. So again, mean, we're going to be finding the average distance. Median would be finding the middle distance, and mode would be finding the distance that appears most often. So if we want to figure out which way should best describe those results, let's start off by actually finding what those values are. So let's start off by finding the mean by adding all of them up. And we get a sum of 68. And there are 5 values. So now our total is 13.6 feet. Now let's find the median. And 16 is our median value. And since the data set has no repeated value, there is no mode. So now let's take a look at our means of measuring center. We've got our mean, our median, and there's no mode, so we can just toss that out as a way of describing Kara's results. So looking at the mean, we have 13.6, and looking at the data. As a reporter, you're going to be reporting out what distances were recorded, and 13.6 doesn't really match any of the distances that the airplanes flew. So the median is less than 4 of the 5 values, so it's not really a good description of the center of data because it doesn't really reflect the data that was recorded. It's less than that. The median is closer to most of the values, so it's a better way to describe the results so people reading this report have a better idea of the distances that were flown by these airplanes. So Thomas should use the median to best describe her results. All right, switching gears to 13.6, now we're going to apply those measures of center. Julie is collecting data on her favorite sports teams for a report. The table shows the median and the interquartile range of the heights of players on her favorite baseball and basketball teams. How do the heights of the two teams compare? All right, so again, our median data is going to be the list of the athletes' heights in order from least to greatest and the middle value. And our interquartile range is going to tell us how close in distance or how far in distance those heights are away from each other. So here for baseball, we see that the median distance is 70 inches and the interquartile range is 6 inches. So that means that those heights, distances, range in about 6 inches. So they're a little bit farther apart from each other, meaning that people on the baseball team, their heights vary, right? They're not all the same height. Whereas the basketball team, their median height is 78 inches and their interquartile range is 4 inches. So since their interquartile range is 4 inches, that's telling me that they're all relatively the same height on the basketball team. So let's fill in these blanks here after I've already kind of lectured about it. So the median of the basketball, and I'm just going to put basket for short, basket B, is 78 inches. Oh, not 78 inches. Is blank inches greater than the median of the baseball. So basketball, they have about 8 inches more than baseball. Now let's look at the interquartile range. The interquartile range of the baseball team is blank. the interquartile range of the basketball team. So the baseball team has a greater interquartile range than the basketball team. So the heights of the baseball teams vary more than the heights of the basketball team. So that tells us that the players on the blank team are typically taller than the players on the blank team. So again, our median tells us that the basketball players are taller. Basketball are taller than the baseball, base B. And the heights of the blank team vary more. So the heights on the baseball team vary more than the basketball team. Last question. Kamira and Joey sold t-shirts during lunch to raise money for a charity. The table shows the number of t-shirts each student sold each day for 2 weeks. Find the mean and range of each data set and use these measures to compare the data. All right, let's start off by finding Kamira's mean. And 10 data points. So that's 30 over 10, which simplifies to 3. Now Joey's. And that gives us a sum of 30 as well, with 10 data points, and also has a mean of 3. Now let's take a look at their range. Kamira's greatest value is 5, and her least value was 1, so her range is 4. Joey's greatest value was 13, and the least value was 0, so minus 0 gives you a range of 13. So now we're going to be comparing the mean and the range. So the mean of Joey's sales is blank. The mean of Kamira's sales. Well, they're the same. They're equal. Same as. And the range of Joey's sales is greater than the range of Kamira's sales. So the typical number of shirts Joey sold each day was the same number of shirts that Kamira sold, because they have the same average t-shirt sales. However, since Joey's range, However, since the range of Joey's data was greater than Kamira's, the number of t-shirts Joey sold varied more from day to day than the number of shirts that Kamira sold. So Kamira had a consistent selling of 1, 2, 3, 4, 5 shirts, whereas Joey, some days he sold 0, and some days he sold 4, and one day he sold 13. So his data points are more spread out, meaning he doesn't have a consistent sale like Kamira does. All right, here is your one practice problem. It can be found on page 741. Enjoy the rest of your day.